Welcome back to Lesson 4-5. This is I can use proportions to solve problems. We'll also call this our unit of solving proportions. So we learned about proportions earlier in the chapter, and now we're going to work at solving them. So you want to think of equivalent fractions, and you want to know your cross products and multiplication. Have your vocabulary and notes out and ready to record important information and write down questions that you can bring to class. Solving proportions. So again, a proportion is an equation stating that two ratios or rates are equivalent. Remember, a ratio is a comparison of two numbers. A rate is a comparison of two numbers by division with different units. And equivalent means that they are equal. So 6/8 and 3/4 are equal because if I divided both 6 and 8 by 2, it simplifies to 3/4. So if we drew a picture, that would make 6 makes up the same portion of 8 as 3 does of 4. Make sure you put that in your vocab. Consider the following proportion. So what this means is that if A over B is equal to C over D, then A times D is also equal to C times B, or B times C. Erase that so you make sure you can see that. So this is something that you want to have down and understand. So it says that the products of A and D, meaning multiplied together, and B and C are called cross products. Notice how I went like this, across multiplied. So cross products, which is multiplication. The cross products of any proportion are equal. You can use cross products to solve proportions in which one of the quantities is not known. So when we have a variable in place of one of these numbers, we can solve for that number by doing cross products and solving an equation, which we have experience with. So if you notice, 6 times 4 is 24, and 8 times 3 is also 24. That means that these two ratios or rates are proportional. They are proportion. They are equal. So write and solve a proportion. Example 1. The temperature after 2 hours, the air temperature has risen 7 degrees Fahrenheit. We're going to write and solve a proportion to find the amount of time it will take at this rate for the temperature to rise an additional 13. So we're looking for the amount of time. So we have to figure out what we're given. We're given 2 hours, rose 7. We're looking for the amount of time to rise 13. So to write a proportion, we're comparing temperature to time. Time per temperature doesn't make sense. Temperature per time. So we know that it was 7 degrees in 2 hours. So how much time, replace it with the variable, to go 13 hours. So we write the proportion. Then we use our cross products and we multiply across. 7 times t is 7t. 2 times 13 is 26. This is a one-step multiplication equation. So to undo multiplication, we divide each side by 7. And we get t is approximately, so it doesn't go in there evenly, 3 7/10. So it'll take about 3.7 hours to rise an additional 13 degrees Fahrenheit. Why don't you try these and pause and then come back and check your answers. So it's already set up as a proportion. So I'm going to use my cross products. And I get x times 10. Notice how we should not use x for multiplication anymore because it's a variable. Is equal to 4 times 9. So what we get then is 10x, the number comes first, is equal to 36. One-step equation, we want to undo multiplication, so we divide by 10 on both sides. 10 divided by 10 is 1, so we get 1x. Any number divided by 10 is really 1 decimal place. So 36 divided by 10 is 3.6. You could plug it back in to check. So you could do 3.6 divided by 4 on your calculator, and then do 9 divided by 10 on your calculator, and they should be equal. And if they are, then you know you did it correctly. So over here, I'm going to do 2 times y is equal to 34 times 5. So I get 2y is equal to 170. I want to get y alone, so to get rid of 2, 2 divided by 2 is 1y. 170 divided by 2 is 85, because 100 divided by 2 is 50, 70 divided by 2 is 35, and together they make 85. Again, you could plug it in to check. If you did 2 divided by 34, and then you did 5 divided by 85, you should end up with the same thing on your calculator, so you know you did it correct. Another one, making predictions. So during a blood drive, the ratio of type O donors to non-type O donors was 37 to 43. About how many type O donors would you expect in a group of 300 donors? So we're making a prediction. What we're given right now is a ratio of 27 to 43 type O to non-type O. Then we're given we're wondering how many type O if there were a group of 300 donors. So we want to write and solve a proportion. So we want to let T represent the number of type O donors. What we're looking for, we need a variable for the unknown, but we need a ratio to compare what we're given. So we're given a ratio comparing non-type O to type O, or vice versa, but we're trying to find out type O to total. So if in our ratio this one represented the type O donors, that's going to be our numerator, and we need to add our total. So we need to add our type O and our non-type O together for 80. So that means we know that 37 of the 80 were type O. So 37 of the 80 should be equal to how many type O out of 300? So we do our cross products, 37 times 300 and 80 times T. And we get 11,100 is equal to 80T. Divide each side by 80, because 80 divided by 80 gives you 1T. And 11,100 divided by 80 gives you 138 and 75 hundredths. Since you can't have 75 hundredths of a person, and this question has to do with people, you have to think about the reasonableness of your answer. So what you'd say is you'd expect to find about, and you round up, 139 people with type O blood in a group of 300 donors. So about that many, not exactly that many. Go ahead and give this one a try. You can pause and come back if you need to. So recycling 200 pounds of paper saves about 17 trees. Write and solve a proportion to determining how many trees you could expect to save by recycling 5,000 pounds. So we're doing pounds per tree. So we're going to do, it was 2,000 pounds, saved 17 trees. How many trees can we save if we recycle 5,000 pounds? So notice I kept pounds on top, trees on bottom. Cross products times T equals 17 times 5,000. So I get 2,000 T is equal to 85,000. Oopsie. Ignore that extra zero. So to get T alone, I divide by 2,000. And I get T equals 42.5. So that means recycling 5,000 pounds of paper saves 42.5 trees. All right, a little bit more, and we're going to use that word constant again. So you can also use the constant ratio to write an equation expressing the relationship between two proportional quantities. The constant ratio is called the constant of proportionality. Remember, this is a wordy chapter. Make sure you're using your vocabulary. JC bought 8 gallons of gasoline for $22.32. Write an equation relating the cost to the number of gallons of gasoline. So we're relating cost and gallons of gasoline. How much would JC pay for 11 gallons at this same rate? So we know that she bought 8 gallons for $22.32. So we're going to find the constant of proportionality first. Kind of like the unit rate. How much did she pay for one? So cost in dollars per gallons, because we're looking for how much per gallon, not gallon per dollar. So we do that, and we find out that she paid $2.79 per gallon. So in words, this means that the cost is $2.79 times the number of gallons. So we're trying to figure out the cost depending on the gallons. This just gives us a way. So hey, if she knows that it's $2.79, which is way more than it is right now, about $1 more, at this time in 2015, she could figure out, well, how much money am I going to have to spend depending on how much gas I need. So these equations are really helpful for planning ahead. So to find the cost, if we want to know how much for 11 gallons, what she does is replaces that value into the variable that represents gallons. So she says, how much will it cost me at $2.79 a gallon for 11 gallons? Then you multiply and you get a value. So it says that the cost for 11 gallons is $30.69. So let's give this one a try. Olivia, hello Olivia, type 2 pages in 15 minutes. Write an equation relating the number of minutes, M, so M represents minutes, to the number of pages, P, typed. So when we're comparing M to P. If she continues typing at this rate, so we have to find that first, how many minutes will it take her to type 10 pages and 25 pages? So right now we know we're comparing minutes to pages, and this is the information. So we do 15 divided by 2. We find out that she's working at a rate of 7.5 minutes per page when she's typing. So this means that the number of minutes that she's typing will depend on if she's working at 7.5 per page. So if it took her 7.5 minutes for one page, which we just found out right here, we can multiply the pages to find out how many more minutes it will take her. So say it's going to take her 10, or she's going to type 10 pages. So we do how many minutes at 7.5 minutes per page if she's typing 10 pages. So we find out the minutes is 75. So that means 75 minutes for 10 pages. So if we wanted 25 pages, we do how many minutes at 7.5 minutes per page. So we replace the page, how many minutes to take 25. So we do 7.5 times 25. It would take her 187.5 minutes. So 187.5 minutes for 25 pages. And I think what you'll find is that if you simplify all of those ratios, they will end up to be the constant of proportionality. Way to stick with it, everybody. I know you took great notes, and you're going to bring some awesome questions to class. Have a super day.